Well, good morning, class. At least this morning when I'm making the video. This will be the last two sections we cover out of Chapter 4. The first section, 4.1, was our regular SOHCAHTOA, right triangle trigonometry. And the second section was the law of sines, which helps us find missing sides and angles on triangles that are not right triangles. Today we'll cover law of cosines, which also helps us find missing sides and angles on non-right triangles. And then we'll look at some different ways of finding the area of a triangle. And like I said, that'll be the last unit or last new material we'll cover in Chapter 4. So I'm looking at Thursday to be a day we could take a test. Now when we take our tests, the way that works, we're going to do the best we can, is we'll start a Zoom session, and maybe on that day there'll be a couple of them. Maybe there'll be an AM one and a PM one, because I need to get everyone to do the test of that day, and so we'll try to make it work for everyone. And what will happen is we'll start a Zoom session, and after I see that you're on the Zoom session with me, I'll have you point your computer kind of down at your workspace, and then I will email you the test. And you'll get it, and if you have a printer at home, you can print it and just do it. If you don't have a printer, you'll just get a piece of paper out and say number 1, and you won't have to recopy it. And you'll do the test, and I'll give you an hour or so, and once you get done, you'll take a picture of it like you've been doing your assignments and emailing it to me. So that's kind of the plan for this week, and then we'll move on to Chapter 5, which is something kind of completely new. So, all right. So law of cosines. Well, let me go back a second. Law of sines that we've been working on is really a proportional kind of issue. You were usually given some angle. I don't know, 15 degrees. And then you're given a side, maybe that's 6 centimeters. And then, maybe you were given another angle, I don't know, 21 degrees. And then, you're expected to solve it from there. We talked about as long as you're given a matching pair, things go pretty straightforward because it's proportional. 6 centimeters is to the sine of 15. Is to the sine of 15 degrees, as what is to the sine of 21 degrees. And you kind of go through it. We did talk pretty extensively about the angle side, how you really have to be careful when you get that case, and there's a little more work involved with that. But the key was this: can you always get the matching pair? And then you can make it a proportion and go. Well, the law of cosines comes in when the law of sines kind of fails. If I were to run 100 yards this way and then 25 yards this way, and then the question is, how far back do I have to, how far back do I have to run? Maybe I know I run 200, I don't know, 125, I don't know, 118 yards back or something like that. Okay? So in other words, if you're given all three sides of a triangle, okay, and you're asked to find angles, like what angle did you have here? What angle? I know it's kind of a stupid example, but I guess what I'm trying to get at is you have a situation where I was trying to think if that was halfway realistic, where you don't have a matching pair. It's not like here where I can say, oh yeah, sine of 6 is to the sine of 15 is what is to the sine of 30. I can't use the law of sines. And so that's where the law of cosines comes in. And I think the other day I mentioned the law of cosines, although in your book it won't do this, but these three are the same as these three. This is, this equation right here has just been solved for the cosine of A. And so it's kind of nice. And on that cheat sheet I said, hey, if you're trying to find a side, okay, use these. If you're trying to find an angle, use these. Okay. The other piece of information I gave you pretty frequently was, if you ever are asked to find an angle, find the smallest angle first. Well, in this situation, this is clearly the smallest angle, and I know that because it's across from the smallest side. And so the other thing is, label your triangles. Even if it's an applied problem, just say, hey, I'm going to call this A, I'm going to call this B, I'm going to call this C, this is going to be little a, this is going to be little c, this is going to be little b. Okay? And at that point, once you've done that, you say, well, if I'm trying to find angle A, I'm going to pop right into this thing. Okay? Cosine of angle A, which I don't know, equals, once again, the thing that sometimes people have trouble with law of sines and law of cosines is just getting it into their calculator. So when I take b squared plus c squared minus a squared, like I said, I'm just following right off there. B squared plus c squared minus a squared, and that's all divided by 2 times b times c. All right. Now here's the deal. If you don't get parentheses, if you're trying to put this all in at once, if you don't get parentheses around that numerator and that denominator, you're not going to get the right answer. Okay, so you've got to be very careful with that. If I just say 118 squared plus 100 squared minus 25 squared, and then I say divided by 2, well, it's just going to take that answer and divide it by 2. And then whatever that is, it's going to take times 118 times 100, which is not right. So you got to be careful of that. The other thing you got to be careful about is when you get done with this, assuming I've made up halfway realistic numbers, you're going to get a decimal over here. Man, I know cosine ranges between 1 and -1. You're going to get a decimal over here. And so to actually find angle A, don't forget you're going to have to use, to actually find angle A, you're actually going to have to use cosine inverse to get that. So, when you get a decimal, you're like, that can't be angle A. Well, that is an angle A. The cosine of angle A is that, so you work it backwards. Okay? So the law of cosines is really, it's a plug and chug kind of deal again. And, yeah, I guess that's the thing. Now, the assignment, and I know I gave it to you already, but the assignment that we did off the law of cosine section was page 273. And we did 10 through 40 multiples of 5. Okay? So that kind of takes care of section 4.3, the law of cosines. The next thing I would like to look at is section 4.4, and it is area of triangles. All right. So, traditionally you've been taught, okay, if you want to find the area of a triangle, take the base times the height, and then cut it in half or divide it in 2. Okay. And I think, seeing where that comes from isn't that difficult. Most of us feel pretty comfortable with saying, oh yeah, this is a base and this is the height of a rectangle, and we know base times height gives us the area. So if I were to cut it in half, oh yeah, the area of a triangle would be base times height divided by 2. Okay, that doesn't seem crazy. About the only thing that sometimes comes into play is if you draw a triangle with an obtuse angle in it. There are times where I've seen students say, well, if this is 8, and then all of a sudden on the diagram, maybe this has a length of 3. Okay? And kids will say, well, 8 times 3 is 24, divided by 2 is 12. But this measurement doesn't really matter if you're trying to use this. The height of the triangle is always measured at a perpendicular. So you would actually have to find, that height, base times height divided by 2. So, occasionally you'll see that problem. You'll see that problem sometimes. But section 4.4 is kind of set up to find areas of triangles in different ways. Okay? So yeah, base times height divided by 2 is this old standby and works well. But what are some other possible ways of finding the area of a triangle? And so if I have a diagram here and I'll just draw a triangle, try to make it, oh buddy, there we go. And maybe I'll call this the base, and obviously then I'll call this the height. And if the area of the triangle is, I'm going to try to do a little derivation here, is base times height divided by 2, which we are aware of. Are there other ways of finding this? Okay, and so let's say I were to have this angle. Let's say I have an angle here. I'll call this one angle C, I guess. And if that's B for base, I'll just maybe call this angle B and this angle A. Not that I really have to, but okay. So, we think, well, what's another way to mention or to find the height here? Well, from angle C, I'll lay over there. From angle C, opposite would be the height, and the hypotenuse would be A. So I could say, the sine of whatever angle C is H over A. Okay? That's just, right triangle trig. Opposite over hypotenuse. H over A. Okay? And if I do a little rearranging, I say, well, that means the height is always going to be the sine of angle C times A. Yeah, okay, yeah, that makes sense. I mean, height is that. So using a little bit of substitution, you're like, okay, well, that means the height is the same as, so the area of a triangle, instead of saying base times height, we could say base times A times sine of C, and I'm going to put it in order, I guess, A times B, okay, times sine of C, and then it's all divided by 2. Okay. And so what you have there is a way of finding the area of a triangle given a little different information. Now, they do this for kind of all 3 scenarios. Instead of me writing them all out, I'll put them under here. Okay, and you can see, okay. One alternative to finding the area of a triangle is, and by the way, this works really well when the information given was a side and an angle on a side, okay, I can go ahead and say, okay, if K in this case is standing for the area, okay, and so you take 1/2 of this product, of this 1/2 side B times C times sine of A, 1/2 of A, and this is once again why labeling your triangles I think is important, okay. Now you're saying, well, okay, that's great, but there's still no, how do I find the area of a triangle when I don't have an angle? So for example, where'd that sheet go? For example, here I made a problem up that had no angle in it. Now, there's ways of finding the angle. We, like I said, we did it right here. But there's a formula called Heron's formula. I don't know if that's pronounced right, so that's how I pronounce it. And I think somewhere there's a little bit of history. Heron's formula, also known as Hero's formula, is due to Heron of Alexandria, 1st century AD, who was a really smart guy, apparently. That's on page 278. And this is what Heron's formula says. If you have a triangle, and you know all 3 sides, so this is another way of finding the area of a triangle. Heron's formula. Here's what you do. And you know what? I over the years, I've meant to kind of look into why this works, and I haven't dug that deeply into it. But basically what you do is you add all 3 legs together. Okay, so you're going to say A plus B plus C. And you would think you would divide it by 3 to get like an average, but it doesn't. Okay, in Heron's formula, you add all 3 legs together and you divide it by 2. And then that gives you what in Heron's formula they use as S. Now you're saying, well, what is S? Well, S is the factors, or makes up the factors, that we multiply to find the area, which is really kind of interesting. So you add up all three sides, you divide up by 2. The other thing, once again, I'm going to stress this because I know we've had trouble just running our calculator sometimes. When you're doing a problem like this, you have got to get the answer to that, okay, that whole numerator before you divide by 2. If you just say 3 plus 7 plus 9 divided by 2, the only thing it's going to do, well, yeah, if you put it all at once, it's just going to take the 9 divided by 2. You've got to get parentheses around that. Now, some calculators might be a little different, but that's to be safe. So anyway, you find this S value, and then you say, well, I'm going to take the S value, then I'm going to take it times, and this is where you take that S value and subtract the length of side A. And you take it times S times the length of side B, and you take times S times the length of side C. And by multiplying those 4 products together, those 4 numbers together, and then square rooting it, it gives you the area of the triangle. But like I said, there is a proof, I think. Whoa. It does say a proof of Heron's formula is given at the end of this section, but I haven't looked at it, I guess, that closely. Maybe I should. I guess I have the time now. All right. Once again, pretty straightforward stuff. Now, there is one problem on your assignment. Now, let me give you your assignment. It's on page 278. This is section 4.4. And on 278, and we have you do every other even, so like 6, 10, ... 14, or not ... 14, ... through 22. So not very many problems. That's every other even. Okay. And then 41 is about a pretty famous building in New York. You've seen pictures of it. It's built on kind of the end of a triangular block. But then there's this number 45. Okay? And it's a problem about a cow. And I saw it last year, and it looks hard. I mean, it looks hard. But I gave it to my class anyway. And Addie Dean, I'm trying to remember who else, a few others, took it under their wing, and I think they solved it. Okay, it is an odd. I mean, you can look in the back and see if you got it right. I think they solved it. But to be honest with you, I don't, like if I were to try it right now, I don't know if I could do it. It took quite a bit if I remember right. So if you want to have a challenge, okay, it's a pretty simple problem. They just have a cow tied to a barn, and it's grazing in a circular fashion until its rope goes around, like barn, cow on a rope. And as this cow swings, you know, it can swing all the way out to here. And the radius would be the same. I think it's a 100-foot rope. And it could swing all the way around to here. And that's 3/4 of a circle. That's not a problem. Okay, you can find the area. You're going to know the radius. But then the problem is the cow continues to graze. Its rope gets pinched here. So it no longer has a radius of, I think it was 100 feet. It now has a radius of 90 feet. And it starts to go, you know, that radius starts to come out this way. But here's the deal. So it's going to go to a certain point there. And then the same thing here. I mean, if the cow's here and it goes to that place, okay, or if it comes here, goes here, and then starts to go that, so it becomes a different radius circle, which seems to make it a bit more difficult. So it's optional. It's kind of interesting. I mean, you got some time. They make a little note of it in the book, so there must be something kind of special. I just did the whole thing and you didn't see me. I'm sorry. So we had a square building. We had a 100-foot rope. And I was basically, as the cow wanders, it can graze anywhere in this 3/4 area of a circle without, you know, a radius of 100. But as it hits the corner, there's a pinch point, and that radius is no longer 100. Okay? And it hits coming this way. As it hits this corner, it keeps going. That rope is no longer 100. So you get smaller radii things. And there's a drawing of this in the book. So it might be worth challenging yourself if you want. But all right, there's the video. Have a great day. I think we will Zoom today at 10 o'clock, but it might be very short because you don't have any homework to be working on. There might be some past homework people have questions on. All right, have a good day. Bye.